Hello students, welcome back to my lecture, that is artificial intelligence. In the previous lecture, we have discussed about the informed search techniques or heuristic search techniques, in which we have discussed about the hill climbing search techniques. So let's continue our heuristic search techniques, that is our best first search techniques. Actually, best search techniques is the combination of the advantage or the features of the depth first search and breadth first search. So let's see firstly that what is the advantages of DFS and BFS. So DFS requires less memory, as we already discussed about the memory occupied by the DFS and BFS. So DFS required less memory. Okay. Then second one is DFS allows a solution without examining all the nodes. That means if DFS has a solution, then it terminates the searching without thinking about anything. Okay. So it is only search a single solution. And what are the advantages of BFS, breadth first search? It does not get trapped at dead end. Okay, we have discussed about the dead end in the DFS. What is the dead end? Dead end is the node where there is no any successor of the node. But in a BFS technique there is no tapped at the dead end, because BFS is working on the basis of the level wise search. And the second one is, if there is a solution, definitely it will find the solution. Okay, and if more than one solution, then it will give minimum solution. So BFS is best for given the solution in the form of minimum cost. So these are the advantages of the DFS. And in the best first search, it includes the advantages of the both search techniques. So in case of the best first search, it combines both the advantages of the BFS and DFS to follow a single path at a time, but changes path whenever some computing path looks more promising than the current node. So that we have discussed that best first search includes advantages of BFS and DFS, but in best first search, a single path at a time, but it can change anytime its path. So that is the difference. In best first search, one move is selected, but the other node are kept in consideration. So that means it moves to a single node, but all its successor or the other nodes are in the considerable form. It not discard the node, so that they can be examined and expanded later on if the select path become less promising. So unlike hill climbing, this algorithm however returns all estimated computed for previously generated nodes and make its selection based on the best among all of them. So that is the difference. So let's see best first search algorithm. So let's start. Put the initial node on the start list, that we have already know. Start with the start node, and if start is empty, that means there is no node or single node, or start is equal to goal node, that means start is empty, that means there is no node, and if start is equal to goal state, that means a single state, that is already a goal state. Then terminate the search with success. Remove the first node from the start and call this is node A. So then if A is equal to goal, then terminate the search with success. Okay. Then if it is not, then A has successors, generate all of them. Okay. Then find out how far they are from the goal node. So compare with the goal node how far they are from, and sort all of them children generated so far by the remaining distance from the goal node. So sort them according to their remaining distance from the goal node. Name this list as a start. Okay, so newly generated list is called as start1. Replace start with start1. So replace the start with the start. Okay, then go to the step 2, then goes to the step 2 and continue until we reach to the goal state. So let's see example for the best search. So this is our problem or problem tree. Okay, and this is our goal start node, where these are the another nodes, and here given the cost of the each path. Okay, from start to C 5, start to B 6, A 3, then A to D 9. So these are the value, or we can say that cost of the each path. So let's start solution of this path. Okay, so this is our goal node. Actually L is our goal node. So we need to find the solution from start node to reach the goal node with minimum cost. So what is our aim? Reaching to the goal node with minimum cost. So let's see. So let's see the solution of this problem with best first search. So here is the problem. So let's start the solution. So first we put our start node in the start. Okay, then process start with its successor. Firstly we check start node is equal to goal node or start is empty. So here start node has 3 successors, so start is not empty, that is true. Okay, that is true. And start is equal to goal node? No, because our goal node is L. So what we have to do? We generate all successors of this start node. Okay, so there is a 3 successor A, B and C with cost of 3, 6 and 5. So put it to the its children A, B and C. Then sort them according to their cost. So A has minimum cost 3, then C with 5 and B with 6. So choose minimum cost or minimum promising value of the node, that is A3 for the expansion. Then start with node A, then again match with the goal node. Not it is a goal and it is empty, not. It has 2 successor, that is D and E. Okay, then put into the available node and sort them according to their cost. So C has minimum cost. So next chosen for the next expansion, that is node C with cost of minimum. Then and here you can see that firstly we go for the node A for the searching the or for the solution, but in the next step we find that C is the most promising at the this position. So we switch the our path from A to C. Okay, then when we process C, then C has another successor because C is not a goal state. So find the successor. So here is a only single successor, that is H, and put into the available node, that is B, H, E and D, and sort according to their minimum cost. So here we find that B is a promising or minimum cost node. Then again process to the B. Then B has successor, generate them F and G, put into the available node and sort the node according to their cost. Then cost of H is a minimum. So next process H, and H has 2 successors, that is I and J. Put into the available node and sort them according to their distance or cost from the goal node. Then process, choose node I for the process. Then I has 3 successors, K with L, L0 and M with 2 cost. So sort them, and which has the minimum cost, that is L0. 0 has a minimum cost, which is node L. Select node L for the process. Then compare. L is a goal state. Yes, it is true. So that means terminate the search with the success and we have reached to the goal state. So what is the path from start node? That is S to C, C to H, H to I, then I to L. So this is our minimum cost path to reach the goal node, and there is a solution of the our problem. So using best first search we can solve the problem by using this, applying this technique. Okay. At any point of search process, the best search moves forward from the most promising node of all the nodes generated by them. So it can anytime switch their path whenever it find the promising path. Okay. So thank you.